In this video, we're going to solve a relatively complicated polynomial inequality as shown. Now, the first thing we want to do is get all the terms onto one side of the inequality, make the other side equal to 0. Okay, there we go, like that. Okay, so now what we want to do after this is begin factoring. First thing we do, of course, is common factor. We can common factor out a 2x squared, and we're left with 6x to the 4 plus 5x cubed minus 13x squared minus 17x minus 5 inside that bracket. We've got a fourth degree polynomial. We realize if we let x equal -1, that fourth degree polynomial equals 0. So our factor theorem tells us that we can do some synthetic division and figure out what the other factor will be. So we go through the steps of synthetic division. If you haven't mastered this yet, it's a very important skill. Now we can say that 2x squared times x plus 1 times 6x squared minus, 6x cubed minus x squared minus 12x minus 5 is greater than or equal to 0. And we see, lo and behold, if we let x equal -1, that cubic equals 0. So looks like x plus 1 is going to be a factor twice. That's kind of cool. So we go with it. And we do our synthetic division again. We've mastered this. And so now we see that our polynomial inequality is really 2x squared times x plus 1 quantity squared times 6x squared minus 7x minus 5 is greater than or equal to 0. And we can do trinomial factoring on that trinomial at the end, and we get factors of 2x plus 1 and 3x minus 5. Now that whole thing is going to be greater than or equal to 0. And at this point, what we do is we make ourselves a number line. And I'll put it way up at the top. That's not much of a line, but you see what I'm trying to do. And I get the zeros of that that final line here where I have the left-hand side all factored. I get the zeros of that, and I put them in numerical order from least to greatest. Okay. Now, if I let x be a value less than -1, let's imagine I let x be a value like -2. What I would have is 2. Then I would have a negative value squared. Then x plus 1, again, I'm letting x be -2. X plus 1 would be negative, so that would also be squared. 2 times -2 plus 1 would be negative, and 3 times -2 minus 5 would be negative. Now I ask you, is 2 times a negative value squared times a negative value squared times a negative value times a negative value greater than or equal to 0? Absolutely. So now we do it again, and we use a value in between -1 and -1/2, because we're going to be testing this second interval here. Now, when we do that, our x is still negative, so we've got 2 times a negative value squared. At this point, though, our x plus 1 will be positive, so we'll have a positive value squared. Our 2x plus 1 would be negative. Again, we're letting x be a number in between -1 and -1/2, so let's say -0.7. And then 3x minus 5 would be negative. And I ask you, would this set of values, 2 times a negative squared times a positive squared times a negative, be greater than or equal to 0? Yes, it would. Now we let x be a number in between -1/2 and 0. Perhaps we let it be -0.3. Well, 2x squared will be 2 times a negative value squared. X plus 1 will be positive, so that'll be squared. Now 2x plus 1 would be positive if we let x be a value like that, and 3x minus 5 would be negative. Now I ask you, is this a positive number? Is it greater than or equal to 0? The answer is no. 2 times a negative value squared times a positive value squared times a positive value times a negative value is not greater than or equal to 0. Now we let x be a number in between 0 and 5/3. Perhaps we let x be the number 1. Okay, well now all of our factors are positive except for that 3x minus 5 on the end. That stays negative. So is this 2 times a positive squared times a positive squared times a positive times a negative greater than or equal to 0? No, it is not. And finally, when we let x be a number greater than 5/3, we get all positive factors. And when we multiply those, we do get something greater than or equal to 0. Now, if using the signs the way I've done here, if that is confusing for you, you have the option to plug a value for x in and see, literally test a value, evaluate it, and see if it makes the statement true or false. So at this point, I'm going to say that my answer is all these check marks, but I have to ask myself, are the values of x that made the circled inequality right here equal to 0, in other words, the numbers on the number line, are they in the solution set? The answer is yes. The quick answer why is because we started with a polynomial inequality that included equals in its inequality operator. It's greater than or equal. But a longer answer would be literally if you plug any one of these values in for x to the original inequality, it will become a true statement. If you plug any one of those values for x into the inequality checkmarked, you'll end up with the statement 0 greater than or equal to 0. That is a true statement. So as a result, we're going to include all of the checkmarked intervals. We're going to say x is less than or equal to -1/2, x is equal to 0, x is greater than or equal to 5/3. And that is our final answer right there. Notice, though, in giving the final answer, we did not say x less than or equal to -1, -1 less than or equal to x less than or equal to -1/2. That's a very inefficient way of saying it. Because we have a couple of check marks up here in consecutive intervals, and we're including the boundary value of -1, that's really just one interval for purposes of our efficiently stated solution set. So that's how you do that type of question. I hope that made sense for you, and good luck.